Okay, kids, what I'm going to do is solve the DAPP for day 6, 6-9. And I've had a number of students ask about this one, so I figure I'm going to try to do a solution instead of just putting the answer and see if this works, and then maybe do this in the future as well, but we'll see. Okay, so first of all, what we're doing here is we are releasing an electron and a proton from the midway point between two parallel plates. I think it says the top is plus and the bottom is minus. And they're reaching the ends at the same time, but the electron is released from rest and the proton, so the electron VI is 0 and the proton, we want to find VI. So our ultimate goal is to find the initial velocity of the proton. Okay. Now, these are in between parallel plates that have a 175 volt potential difference between them. If we do V equals ED, the electric field is consistent no matter where they are in the in between the plates. So the one odd part of this concept with potential difference is that even if they're here or here or here, anywhere along this, the electric field is the same. So it doesn't increase in value as you get closer to one of the plates. It's just always constant. So if we just do 175V equals ED, then the electric field is 175 over D. I'm going to leave out the volts just so we don't think that there's another variable. This E, 175 over D, will help us figure out the acceleration of the particles. And they're going to have the same force, but a different acceleration because their masses are different. So when I solve this, E equals F over Q will be the same for each because they both have the same 1.6 to the negative 19 coulombs. The electric field is 175 over D. So their force is going to be 175 times the charge. And then we're going to do F equals ma to figure out the acceleration. So each is going to have their own unique acceleration. And what I want to do is find the acceleration of the proton and acceleration of the electron. Now, if I remember that let me just do this. Mass of the electron is 9.11, 10 to the negative 31. That's the electron. The mass of the proton is 1.67 times 10 to the negative 27. That's the proton. With that being said, if I multiply the Q up here, 175 times 1.6 to the negative 19, and then I divide the mass to the other side since F equals ma, so F equals ma here, if I do 175 Q over D, Q divided by m, I'm going to get the acceleration of each. Okay, 175 times 1.6 to the negative 19 divided by each of the masses should get me the acceleration. And what I want to do is verify it. I have it written down here, but I want to make sure I have the right number. So 175 times 1.6 to the negative 19 divided by 9.11 e negative 31 gets me 3.07 times 10 to the 13. And I have 3.0735 written down. So I'm going to do that. 3.0735 times 10 to the 13 over D. And then for the proton, I had 1.677 times 10 to the 10 over D. All right, so that gives me the acceleration of each. Now, the accelerations, I'm going to rewrite here. So A plus 3.0735 times 10 to the 13 over D. A minus, which is the electron, 1.677 0.77, I have that backwards, don't I? Yep. Times 10 to the 10 over d. The electron goes greater. So it's the electron is 10 to the 13. I just had these written backwards. Electron, proton. All right. And the reason I realize that is because the electron is going to accelerate much greater because it has a much smaller mass. Now, because the electron went from rest, what I can do is say d equals VIT plus 1/2 AT squared to figure out the time. It goes half the d though, equals 0, 1/2, and this is for the electron, so it's 3.0735 times 10 to the 13 over d times t squared. Now, if I solve in terms of t, so this is we're gonna basically multiply this side by d, so you end up with d squared here. Multiply d on this term, that'll cancel that d. This will turn into a d squared. The halves are on both sides, so they'll disappear. And if I take the square root of everything, so square root of both sides, you get d equals, and then the square root of this 3.03, square root, it happens to be in my calculator still, is 5,544 times 10 to the, that's 1, 2, 3, 4, 5, 6, 1, 2, 6, 10 to the 6, t. Now what I did is I rearranged it because I wanted it in terms of t, so I could plug it into the next equation. So what I'm going to do is divide this over here, so divide this here, and I'm going to get, so 1 over that number basically. You're going to get 1.8 to the negative 7 d equals t. So 1.8 times 10 to the negative 7 d equals t. So the time, 1.8 times 10 to the negative 7 d. Now, that's what I can glean from the electron. The proton is also going to experience a 1/2 d, because it only goes half the distance, but it has a VI. So the VI is multiplied by t, which is 1.8 times 10 to the negative 7 d, plus 1/2 a, which for the proton was 1.677 10 to the 10 over d, times t squared, which means we get 1.8 times 10 to the negative 7 d squared. Okay, now this looks kind of scary, but it's going to simplify in about a second. If I do the 1.8 times 10 to the negative 7 squared, so I'm going to square that number, you get 3.2 times 10 to the negative 14 d squared, and then you have the 1/2 here, and you have the 1.677 times 10 to the 10. The VI's here, 1.8, 10 to the negative 7d, and then the 1/2 d. Well, if you look here, and I forgot to put the d underneath, this d squared and this d is going to cancel one of them. And then what you're left with, a d here, a d here, a d here, they cancel. So the d's go away. All you're left with in the problem is a VI. Now the math is scary looking, but you're going to combine this term here. Okay, so you're going to do 1/2 times 1.677 to the 10, E10, E10 times 3.2 E negative 14. And you end up with 2.7 times 10 to the negative 4. The 1/2 is still here. VI 1.8 times 10 to the negative 7. All right. Since this is a positive, we're going to subtract it over here. So it's 0.5 minus the answer we just got. So you get 0.49973, etc. And you're going to divide. So you have a number here. So it's 0.49973,168 equals VI times 1.8 times 10 to the negative 7. And if we divide by 1.8 E negative 7, we get VI is 2.7763, probably too many digits, times 10 to the, and I'm going to go 1, 2, 3, 4, 5, 6 decimal places over, 10 to the 6 meters per second. So, your speed of the proton, the initial speed, in order for them to get there at the same time, was 2.8 times 10 to the 6 meters per second. In terms of the physics of this problem, though, really the pieces that mattered were that you had to know V equals ED, E equals F over Q, F over Q, we'll make it there, and F equals MA. If you were okay with the fact that it was 1/2 D, then we plugged it into equation 4, which is the D equals VIT plus 1/2 AT squared, and you ended up with the right answer. The new stuff is here. This and this are basically review from the forces unit and review from the kinematics unit. And really the hard part here was this algebraic simplification and everything in terms of D's. But the D's ultimately canceled out and you were left with just the VI.